Last week we learned about the boltzmann, so this time we learn about the subthreshold swing and boltzmann limit. Last time we learned about the IDVG characteristics, so we drew like it in enhancement mode, but we have to consider about that position because when the gate bias is less than the threshold voltage, there has a leakage current, so we have to control that leakage current. So we redraw the IDVG characteristic like a log scale. So we can draw like this, and in this part there has a leakage current before when the gate bias is less than the summer voltage. So we can calculate this leakage current by using this formula. It can only use when the gate bias is less than the summer voltage. And we can define the subthreshold swing. That means that when the drain current goes off like 10 times, that the gate bias change. So we derive this drain current and we can make this conclusion. There has a n in these formulas, and I'll explain in the next chapter. So the n means the coupling. So we learned that when the n fat in this situation, there between the dioxide and semiconductor, there has a lattice continuity is broken down. So there has a state that the electron can exist. So there has a capacitance in that surface. So we can call that capacitance like a CIT. It means interface trap. So in that MFAT, there has a three-state capacitance. First is oxide capacitance and depletion capacitance, and last is interface trap capacitance. So the coupling means when the oxide capacitance is under here and remain capacitors are here, but we know that the capacitance is a little bit difficult, so we can make it by using the impedance. So the capacitance impedance is 1 by j omega c. So we rewrite it like this: j omega c ox like this. So that means n equal 1 plus COCTP plus CIT by COX. That means a coupling. So we calculate this coupling and we put them to these formulas. And by this formula, in this case, the ideal state is that when n equal 1, because it means that the oxide at the depletion width and interface traps are both doesn't exist, so the n equal 1 is the ideal state. So when we put them in the subthreshold swing formula, here, and consider that there has a room temperature in here. The result is 60 millivolts per decade. That means the 60 millivolts per decade is the lowest number from the subthreshold swing, so it means a Boltzmann limit.